Okay, hello, and let's take a look at finding the equation of a parabola. So we're talking about quadratics here, and we want to know how to find the equation when given some information. Is it always possible to find the equation of a parabola? Well, it depends on what is given to you. You have to have enough information in order to determine the equation. So let's see. First of all, you need to distinguish between the different forms of a quadratic function. If it's given in standard form, like it says here, standard form, you have this to deal with. Ax squared plus bx plus c equals y. If it's given in vertex form, all of these forms you want to know by heart. This is what it's going to look like. That's the vertex form. How do we read the vertex? You do the opposite of what h indicates to be within your parentheses, because remember it goes with x. When it partners with x like that, you do the opposite. So you do the switch for the h and you do the keep for the k. Okay, so the switch keep. When given the vertex and a point on the parabola, find a, then write in vertex form. At which point you're going to replace the a, h, and k with numbers, and you're going to keep the x and y going. So here's an example. You're given the vertex and a point. First thing to do is recall the vertex form and write it in general terms. Then start replacing what you know. We're going to do the switch keep idea, remember? Switch this one, keep that one. And as you can see, my 5, positive 5, traveled in for h as a minus 5. And my negative 4 stayed as is for k. Okay, so that's your switch h, keep k. Then, of course, I have the x value that I can replace with a 3. And this is what it happened. My x turned into 3. And my y is 8, so I replace the y accordingly. Okay, now I'm down to one unknown, which is my a. You have to find your a in order to know how wide the parabola is going to be and whether or not it's opening up or down. Okay, so after evaluating blah, 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 solve for a happens to be 3. Then you go back to your y equals form, the vertex form, you replace your a, h, and k, and you keep the y and x as is. Now, to kind of connect to the transformations that we talked about, that is what is happening. Compared to the parent function, which of course you know the parent function of a quadratic is y equals x squared. Okay, that's your parent. And so the question is, what happened to the parent function? Okay, what happened? We have a sideways movement, which is horizontal. Okay, that's your sideways movement right here, horizontal. Then you have, oh yeah, so which way? The opposite of what it seems to be. You're going to the right 5 units. Then you have a vertical situation, up or down, right? You have to decide. Well, in this case, it's clearly moving down. Okay, moving down by 4. And then the hard part comes up with your stretches and compressions. The 3 is on the outside, okay? Remember, all of these outside buddies here, we take it as it is. We're not switching things around. Vertical, anything, you just take it for what it is. Versus horizontal, if it's inside, you do the opposite. Okay, so outside factor is 3, and it's a stretch because a is greater than 1. Vertical stretch. That's just to refresh your memory on transformations. Now, transformations, you do need the vertex form for it. So it's one of those things. Better be your best friend. Back to that, we are looking at the vertex form once again. Take your time and write it down and then replace. Okay, that's just a different example with negative numbers this time to give you more practice with HK, switch keep. Okay, so the negative 3 switched, as you can see, and became a positive, plus 3. And the negative 7 here, we kept as is because it's right there, okay. So then you replace your 1 and 1. So happens, can't even make a mistake. X and Y are both 1. Replace them, find A. A is 1/2. Now we want to know, is it a compression or is it a stretch? Again, outside stuff looks like a V. See that? On the outside, what's happening? We have a vertical compression this time, okay, because A is not greater than 1. And we take it as is. We're not changing anything about it. The only change that happens is whatever partners with X, which is a movement horizontally 3 steps to the left. So rework the examples as needed. Here's example number 3. What if we're given the x-intercepts and a point? When you're given the x-intercepts, you don't want to use the vertex form because it's not going to help you. Now you want the factored form, okay? So the factored form shows you the parentheses, okay? 2 of them, unless you have a repeating 0. Anyway, so let's go through it step by step. As you recall, the x-intercept must move in as its opposite here, so that's x minus 3. The other x-intercept, and the way I know it is because the y value is 0, okay? That's how I know it's on the x-axis. So now I notice, oh yeah, look, it moved in as a plus, x plus 1. Now, don't forget that you don't know your a. You cannot just pretend it's 1. You don't know that. So you have to figure it out first. Now you have to have another testing point, a point that is on the parabola. Right now, I don't even know if it's going to go like this or it's going to go like this. And I don't know how wide it's going to be. So right now, it's a big question mark. Without the determination of my A, I won't know what I need to know. So I have to have that extra point. Do I care where it's at? No. It could be the y-intercept. It could be any point on the parabola. But I need that point to find A. Okay? And I'm going to do that. I'm now going to replace my x and y. And notice I'm now able to find A. A is 2. Okay? So now you have to wonder, is it going to be wider or narrower than my parent function? Okay? The parent function has a coefficient of 1. It's y equals 1x squared. This one has a coefficient of 2. Outside factor, what does it tell you? So maybe it is a vertical stretch. Okay, so it's going to be narrower than your parent function. You can graph it with a calculator and check it out. Now, you have to be fluid between factored form and standard form. Okay, you have to be able to rewrite it as such. Just like we did factoring, you have to be able to get from this form through factoring to your factored form. Okay, and you have to be able to go from the factored form back to the standard form. Make sure that that cycle is in place, FOIL to check at all times, distribute your outside factor to get the standard form. The standard form is to be written in descending order, meaning x squared and its coefficient come first, and then based on your exponents, there you go, x to the power of 1 is next, and so on. That much for this example. Hope it helps. Now, how do you check, by the way? You better use the calculator, put in both notations, and if it's the same parabola showing the same table, you got it right. Last example. This one is the most interesting one. Why? Because a parabola is vertically stretched by a factor of 2, reflected about the x-axis, and has x-intercepts at 1 and 5. They want you to find the y value of the vertex. And they want you to provide the equation in all 3 forms, vertex, factored, and standard form. Take this problem full circle and you're good to go. Look at that. Now, you have to work with triggers. So when it says vertex form, it better trigger something. And then you say, okay, let me write the vertex form. There it is. That's the vertex form in general terms. Now, when it says factored form, you better recall what that means. Okay, you write it for yourself like that. Standard form. So look for keywords, translate them as needed, and get started after that. Now, they're not telling you what form to start with, notice, so it becomes your decision. So you have to go back to the information. Vertically stretched, what does that mean? it means I have the outside factor of 2. So outside where? Right there outside. Okay, outside. So the factored form seems to be the one to start with, if you ask me. Reflected about the x-axis. So where is that reflection going to happen? Okay, it has to point down. In order for a parabola to point down, you have to have a negative as your a. So there you have it. It's -2. That much we figured out. Now the x-intercepts. You're going to move them in as opposites because they're partnering with x. Okay, and there it is. X minus 1, x minus 5. Ta-da! You're pretty much done. That is your factored form. That was easy. Now you have to FOIL and distribute outside factor to get to the standard form. Once you're in standard form, you already answered 2 questions. Okay, so there it is. You are in standard form. Boom, there it is. You answered the second part. And all you have to do now is the vertex form. So how do you get there? Well, that's a problem because they don't give you the vertex. And to answer part A, what is the y value of the vertex? Clearly, you need to know the location of the vertex. So there is a little graph that I thought might be helpful. So what you start with is this. You think your way through this whole thing, okay? And this is what you do. You're like, okay, I know the x-intercepts, let me graph them. Boom, boom. One is at 1, one is at 5. And I know that the axis of symmetry is halfway between them. Okay, this is what's happening down here. My axis of symmetry, people, is halfway between the x-intercepts. Now, does it work for any point? Well, any 2 points. Technically, yes. You just have to make sure that the points, whatever is given to you, let's say you have points given like this, one here, one there. As long as the y value is the same, like this, along the same line, then yes, any 2 points can be used to find the axis of symmetry when you add the 2 x values and divide by 2. And then you're done. That's what happened. 1 plus 5 right here divided by 2. And that leaves you with 3 for your axis of symmetry, x equals 3. Now, my problem, however, is I don't know where my maximum is going to be. How do I know it's my maximum? Well, yeah, it says reflected about the x-axis. So that means the parabola is opening down. I do know I have a maximum. I just don't know where. I know it's going to be along the x equals 3 for the x value, but my y value is still unknown. What do I do? So here's what I do. I get started. If you don't know what to do, take the general form, start plugging stuff in. So I know that my h is 3. Now I have to do x minus 3, of course. So that much I know. I know the outside factor is -2. So I got that. I don't know my k. Still a problem. Do I have another point to work with? Oh yeah, let's go back. Look. Da, 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 da. The x-intercepts are at 1 at 5. 1 and 5. So that means 1, 0 and 5, 0 will work. So just pick one of them. Okay, I picked the smallest numbers as always, 1, 0, and I replaced my x and y. You could have picked 5, 0. Now you would still get what you need, which is your k. K is 8, people. And that answers the question, part 1a, question A. Y value is 8. Now, how do I know I got it all right? Okay, I use the calculator. Okay, I use the calculator and I put in all of my values. Okay, so second plus 7, 1, 2 to clear your calculator. Then you would put in all of your functions. Let me look that up. What was it again? -2, x minus 1, x minus 5. Okay, so -2, open parentheses, x minus 1, close parentheses, x minus 5. You do that, you graph it, okay? Then I'm gonna do the next one, which is -2 in vertex form, x minus 3 squared plus 8. -2, open parentheses, x minus 3, close parentheses, squared. Get out of the exponent, don't forget that. And I think it was plus 8, unless I'm wrong. Okay, plus 8. Notice that I cannot see the y-intercept when it's in vertex form. Neither can I see the y-intercept when it's in factored form without any work, okay? That's a problem. That's when the standard form comes in handy. I know it's going to be -2 x squared and whatever my vertex standard form was, plus 12x minus 10. Yeah, that's a nice one when it comes to the y-intercept, plus 12x minus 10. Okay, so watch this. If, let's see if I copied it correctly, plus 12x minus 10. If my parabolas are different at this point, I have a problem. That means I didn't do it right. Something happened. Now I really hope that all three of those coincide. We did it! Okay, I can also look into the table. Look, boom. If I look into the table and I see it side by side, oh nice, those are the same values. For every input, I get the same output. Woohoo! That means those are the same graphs, and I got all three of my forms correct. Okay? That's how it works. Now, what if, people, okay, what if you want the calculator to do the job? Let me tell you something. And that could be your extension activity. Write down at least 6, 7, 8 values out of the table, okay? Write it down and then enter those values to use the regression, quadratic regression, okay? 0, -10, 1, 0, 2, 6, 2, 6, 3, 8, 4, 6, 5, 0. Okay, people, let's take a good look and clear the calculator after you wrote down a couple ordered pairs so that we can actually do quadratic regression. How about that? So I wrote down 0, -10, 1, 0, 2, 6, 3, 8, 4, 6, and 5, 0. That's what's on my paper. I'm going to enter that in a minute. So to clear the whole calculator, second plus 7, 1, 2, and then our parabola disappears, unfortunately. Aww. So what we want now is do the regression, okay? Now, how is it done? Let me tell you this, guys. Let's quit out of this second mode. When in doubt, go to stat, okay? Stat. Like when you forget how to do regression, you have to remember one thing, and that is press stat. Now enter. Oh yeah, okay, here's my table. I got that, I got it. Look, 0. I'm just gonna go down the inputs, okay? Because when I press enter, it takes me down to the next input. So I'm gonna do 1 to 5, 0 to 5. Okay, 0, 1, 2. That's what I copied from my input output. 4, enter, 5. Now the last value, you also have to press enter to confirm. Now go to the right. Oh yeah, okay. So now -10, that was my partner, that goes with 0. 1 goes with 0, that's my output for that. Then 6, then 8, 3 goes with 8. Okay, I copied it from the previous table. And what we're, oh no, not 66, I don't want that, it's gonna mess up my graph. 6 only. Enter, and 0. So what we wanted to do is we wanted to prove that we can make the calculator find the equation of the line. Okay, the more values you have, the more precise it's going to be. So I just chose how many? 2, 4, 6? 6 values. There you go. Now what do I do? If I graph it, nothing's going to happen, will it? No, unfortunately not. I forgot. What do I do? What do I do? I go to stat. Okay, again, when you forget, you go to stat. Now, what could I possibly want? How about calculate? I could possibly be interested in a calculation of some sort, and I want it to be quadratic, preferably. Okay, so that's option 5. How did I get there? Okay, I'm going to do it again. Stat. Told you, when you're lost, do stat. Stat, stat, stat. Now, go one time to the right to get to calculations. Yeah, see, that's how, one thing is for sure, you have to have some expectations. Okay? If you don't even know what to expect, you're lost. Just like it would be in life. You have to set some expectations, right? So here, quadratic regression is what you're expecting to see. Enter. Oh, quadratic regression. Just press enter, enter, enter. See what happens. Enter it through. Calculate. Ding, ding. Hey. Negative 2x squared plus 12x minus 10. Negative 2x squared plus 12x minus 10. Told you. That's how you do quadratic regression, people. Okay, with a calculator. Now, you may remember the correlation coefficient R. Okay, but you're like, well, it doesn't show the R. How close are we to the real deal? Yeah, that's tough. You have to go to catalog. Okay, how did I get there? Second, 0 to get the catalog. And now it's a mess. You have to go down, down, down to get to your D. Okay, slow it down a bit. Diagnostic on. Okay, you have to press enter when you get to diagnostic. That's the only way to get your R to show, right? Maybe it's not the only way, but that's the way. Done. It has to say done. That means you've selected it. Okay? You can select it more than once. Nothing's going to happen. Go to stat. Because remember, you don't know what to do. Go to stat. Go to calculate again. Option 5. Oh, nothing changed. Maybe it did. Go to enter, 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 calculate this time. Oh, the R is there. Look at that. And it's at 1, which means guaranteed great result for your standard form. It is indeed negative 2x squared plus 12x minus 10. Boom. So that much for quadratic regression on a specific example, going through all 3 forms and all the good stuff. Hope it helped. All the best to you.